Okay, back to sharing screen. All right, so the figures that are in the PowerPoint were all generated in R. And so this is a R script that's not going to be super useful to you, but I'll put it up after class on Wednesday. But because I basically built this to be a teaching aid, not to be a functional do things in R script. So here's the Beetle data set, relative humidity and weight loss. This is the long format of the data, which really is the only format for regression data. And I showed you some of the outputs last time, so you can get the summary of the model, and it gives you the estimate for the y-intercept and the estimate for the slope value. It tests both of those to see if they're different from 0. It gives you the F statistic down here at the bottom, the degrees of freedom, and the p-value. It was what you would expect to see in an ANOVA table. You can run summary.aov to get the ANOVA table. And then I went through and did a bunch of mathematical machinations in order to do things like plotting a graph where it has the hypothesized line of a slope of 0 at the mean mass loss versus the best fit line, showing you the residuals for the 0 slope line. And then I have another figure where I actually calculate the residuals from the best fit line that looks like this. And then there's another one that has the actual, this is actually what you would get when you do this for real. And it shows you the best fit line, it shows you the data points, and then there's a gray area around the line, that's the 95% confidence interval for the slope of the line. And it just does this automatically when you ask it to do geom smooth up here in the graph. But what we didn't really talk about much was the assumptions that are underlying the doing of a regression. And I think I mentioned them on one slide. There's always an assumption slide in my slides, but of course the data are independent of one another. They are selected at random. For regression, there are a couple of new ones. If you're doing an ordinary least squares regression, the experimenter has control over the x variable. If it's a model 2 regression, a standard major axis regression, remember x and y can vary randomly. But basically, if you're doing an ordinary least squares regression, this is one of the assumptions that everybody on the planet ignores, by the way. And then there's still the normality assumption, and there is still a homogeneity of variances assumption. Now, if the experimenter really is controlling x, a wise thing for the experimenter to do would be to have replicates at each x. So in this case, with these relative humidities and the beetles, it would have been nice if we had had multiple observations, multiple replicates at 0% relative humidity, multiple observations at 25% relative humidity. In which case, you could do a homogeneity of variances test just like you would do an ANOVA, where relative humidity would be the treatment, and then you would look for unequal variances across these different treatments. But when you have only one observation at each point, you can't assess what the variability is in those data. And so one of the ways that you can do this visually is by basically just taking, one of the things you can do is you can save the residuals. So in my data file now, because of all the mathematical machinations I've done, we have relative humidity, we have weight loss, but over here is the residuals that you can get straight out of the model. So I did this up here at the top, where I basically created a new column called Beatles $ residual with the residuals from the model that I ran. And then I also got the predicted values, which is just running the best fit line for each X and giving me what the predicted value would be. And so I added those to the end of this data file. And so one of the ways that you can assess whether or not you have unequal variances is to plot the predicted values on the x-axis and the residuals on the y-axis. And what you should see is you should see a line centered at 0. Well, I just sworn I did that. Yeah. What you should see is you should see a line centered at 0, because that's the nature of residuals, and you shouldn't see any pattern to the points. They shouldn't get further apart as you get to higher predicted weight loss. They shouldn't get further apart as you get to lower predicted weight loss. So this represents a lack of correlation between predicted weight loss and the residual values. And so in many cases, people just assess non-constant variances using a visual inspection of the residual, the pattern of residuals. There actually is a test in R called the non-constant variance test, NCV test, and you can run that on whatever model it is that you are running. So if you had a model specified up here, actually this is model 1, so I have to alter this statement down here. So we can run this on model 1, and it will actually do a statistical test of variances. But once again, it's using the fitted values to assess this. So that's easy enough to do. The other thing that you want to do is you want to then also do a Shapiro-Wilk test on the residuals. And so we can get the residuals, which we've already done. Whoa, what happened there? So we can get the residuals. There should be 9 residuals. I changed my script since last time I ran it. We can also get what is called standardized residuals, which basically not only measures the residuals, but also puts them on a standardized scale of 3 standard deviations to either side of the mean. And either one, it doesn't really matter which one you do, whether you do standardized residuals or residuals. They should both give you about the same answer. This data then looks like it's a little bit less skewed, negatively skewed. And so we can basically run a Shapiro test on that and see if it is skewed enough, and it turns out that it's not. So you can do a Shapiro-Wilk test the same way that you would do a Shapiro-Wilk test in an analysis of variance, except in this case, what you're going to be doing is, once again, working with the residual values, not the actual values. And so this is easy enough to do on a computer. You could also do it just as easily with hand calculations. I'm not going to ask you to do the hand calculations because you've now done Shapiro-Wilk tests a number of times by hand, and I don't feel like beating a dead horse, but just know that you would do it the same way that you would do it for an ANOVA, because in many ways a regression is simply just a different form of analysis of variance. So you can test assumptions in the same ways, in many cases in the same ways that you do for an ANOVA. You just have to ask it for things that you've already asked it for in the past, asking it for things like residuals. and then treating those residuals appropriately. So what I want you guys to do for Wednesday is you have the relative humidity data set, and I would like you guys to take a stab at writing an R script to analyze that data set from scratch and try and create some meaningful graphics. And what we'll do on Wednesday is we'll get together and we'll troubleshoot what challenges you had as you were trying to do that. And I'll also have a script that does the analysis fully. And so we'll go through and do some live coding remotely to get you guys to the point that you have an R script for doing regression. Questions? And the silence was deafening.
Dr. Klawinski.
Yes, sir.
So we have the homework due today, 5 p.m. We have
yes.
Friday the report for the 2A ANOVA analysis.
Yes.
And for Wednesday, the regression analysis.
Just a short R script. So you'll need to build the data file, but the data are in the PowerPoint from last week, from Friday. And so it's 9 data points to put into a CSV file. And then once again, you just need to run a linear regression on that and make a simple graph. And I'm not going to grade that. It's just to give you guys practice, scripting in R.
Yeah, I mean, I'm having a hard time with R with the 2A ANOVA, so
which is
why we're gonna too much.
Which is why we're going to talk together as soon as we're done here.
Yes.
Questions from anyone else?
Will you be posting the video pretty quick?
Yeah, I'll post it as soon as I'm done here. Yeah, it takes it a couple of minutes for it. When you get off of the Zoom meeting, it goes through some video conversion shenanigans, but once it's downloadable, I will download it and pop it up on the YouTube site.
Yeah, because honestly, the graphs are pretty exotic compared to my skill level.
Oh,
so I'm gonna freeze frame your video and steal those codes.
Yeah. Okay, so so these figures, I'm not expecting you to.
Yeah, there's one.
I'm not expecting you to do all of these shenanigans. These are shenanigans that I did so that when we were going through so I write weird scripts that are mainly focused on teaching. So all of these figures from last Friday, going through the process of calculating what the mean is, what the mean of Y is, what the line is passing through that mean of Y, all of these things, these are all embedded in that script that I was just working through. Making these residual lines isn't something that you would normally want to do in creating a regression. And so I'm not expecting you to do all of that. What I'm expecting you to be able to do is to, let me go down to one of these things. So this final version, which is this one right here, that gives you a nice professional looking regression plot.
Right. Yeah.
with the best fit line, with the data points, with the 95% confidence interval, et cetera, et cetera. You see that there are a number of lines that I have commented out. These are all lines that I've commented out because they're doing things like plotting residuals of a zero slope line, plotting residuals of the best fit line, and making the segments to connect the dots with the line so that you can see what the residuals are. You don't have to do all that kind of crap. all you really need is the geom smooth, plotting points, well, telling it what the data are, giving me the linear model, giving me the points, slapping a label on it, slapping another label on it, giving it a title, and giving it some formatting code. So it's really not that complicated. It looks complicated because I've just commented out a bunch of lines that you don't even need to have in yours, that I have in mind because I was building some figures to put into the PowerPoint to teach you guys what residuals are, and to teach you how the regression actually gets calculated. Does that make sense?
Yeah.
Okay. All right, other questions?
I have a question.
Yeah.
Okay, so I don't know if you've already answered this, but like, this is just general for the rest of the semester. When we once you grade things, how should we expect to get them back?
I need to get the gradebook up and running, and like I said, I'm working through a backlog of grading. If there are any serious problems with what you've submitted, I'll drop you an email and saying, wow, you really messed this section up, here's what went wrong, and work on getting that straightened out so that you know what you're talking about. So I'll give you feedback on those things as I get them graded, but I'm behind for a variety of reasons. But I've spent the weekend grading things for my animal behavior class. I'm going to spend the next couple of days grading things for yours. I need to get the gradebook updated on, formed actually, and updated on Moodle so that you have access to those things. So when grades appear in there, you'll know that I've gotten them graded. And then I've got your mid-semester grade was based on, or your 5-week grade was based on those things that were submitted by then, which was essentially the exam and the first couple of problem sets that you did, the coin flipping and the basic stats problem set and chi-squared problem set. And so, yeah, if you see a grade that appears and you don't get a bunch of comments back from it, basically it means that you worked everything out and your calculations correspond to my calculations. And like I said, I'll be getting to that in the next couple of days.
Okay, yeah, I've had some people do like different things, so I didn't know if you were gonna like annotate our assignment and send it back to us, or how you're gonna do it.
Yeah, I don't think that that's really necessary. This is one of those things where as long as you've got the right answer and the structure of your spreadsheet doesn't look exactly like the structure of somebody else's spreadsheet, then we're good. And it's the same thing with like I was telling Grace earlier, with your R scripts, I open up your R script, I run it on your data set as your data set is formatted, and then I'm basically looking for, did you get the right ANOVA table? Does your Shapiro-Wilk test match the results from my Shapiro-Wilk test when I ran the Shapiro-Wilk test on the same data set? And as I go through that, now your write-ups, I'm actually going to be looking at the writing and how you handle all that. So on those, you will get some feedback on the write-ups, but the problem sets themselves, probably not. As long as the calculations match, what you should see is grades in there for full credit.
Okay, thank you.
Okay. This is why people generally do fairly well in this class, is even if they do poorly on the first exam or something like that, there's no reason why everybody shouldn't be getting full credit on problem sets. Because you can always check your work in R. Other questions? All right, so Wednesday we're going to do nothing but working on regressions in R. We're going to start with the confused beetle data set. I'm also going to post a data set about the COVID epidemic that we will play around with after we're done answering questions about the about the beetles. And the reason that I want to do the COVID thing is because there's tons of data that are out there about the COVID pandemic. And they're all time series data, which basically means you can do linear regressions of, for example, days since the first case and the number of deaths or number of identified cases, et cetera, et cetera. So it's just a rare teaching opportunity where one of the techniques that we're studying, linear regression, applies directly to something that is negatively affecting all of our lives. And so when I was talking to you guys about what the college would probably be doing in terms of the COVID pandemic response, and I think I talked about this more with my biology students in animal behavior than I did in here, I basically would come into class on Monday and the students would say, what's going on with COVID? I'm like, well, we haven't done this yet, but I predict that we're going to probably not come back after spring break, for example. I said that on Monday, and then on Wednesday, by Wednesday, we had gotten an email that basically said, you're not coming back after spring break. You won't come back until April 6th. And then I think on that day, I said, you're kidding yourself if you think that it's going to be April 6th. I think it's going to probably be much longer than that. It may very well be the rest of the semester. And the students were like, well, why do you say that? I'm like, well, because I've been looking at the data coming out of China. And all you have to do is look at China's data and basically see that this is going to be a much longer process of getting through this than the college is currently planning for. So I'll be very surprised if over spring break, you don't get a message basically saying you're not coming back at all. And then we went away for spring break, and over spring break, we got a message that basically said you're not coming back at all. And so this particular thing is one of the situations where being good with data and being able to look at data and figure out what data mean in real time has actually been really beneficial in making accurate predictions about what the time frame is going to be for things. There is a model that was published just last week, I guess it was, at the end of the week, where some epidemiologists have modeled the increase in cases by state. And they've made hard and fast predictions about when each state should peak out in terms of the number of new cases, and we'll start seeing the cases decline. And for Missouri, that prediction is May 22nd. And all of this is based on multiple regression models. So I'm going to try and put together between now and Wednesday a data set looking at COVID cases and how they change over time that we can look at using R on Wednesday. And so that will be hopefully kind of fun, probably kind of depressing. And also because it's a real data set, it'll be a little more complicated than the confused beetles being dehydrated data set. But it will also give us some good practice of doing some live coding. So on Wednesday, you need to come prepared to have a script open, and we'll go through some live coding. And then the other thing is be sure to have your microphones on so that as you run into problems as we go through the coding, you can get feedback on it. So that is that. Questions?
Can I stay on for a little bit after class? I might
And
have
listen.
some of the same questions as Athos.
Okay, yeah, sure. Anybody can stay on, and I'll just keep recording as long as that's okay with you, Athos.
No, absolutely, it's fine.
Okay. All right, then I'll get more into detail with Athos, and if you want to hang around, you can. And if you don't want to hang around, leave and go work on your homework.
All right, sounds good.
All right, Athos, share your screen with me.
Okay, let's do this. View options. That's actually right here. Share screen. Is it sharing? You cannot start screen share while the other participant is sharing. Yeah, you gotta shut down
okay.
first.
I'm sharing. Okay. Sorry, I didn't realize I was still sharing.
No, you're
All
fine.
right, now try.
Okay, let's go for the R. Are you watching this?
Yep. Okay. All right. So it looks like, so run it line by line, go through one line, give me line 1. Okay. All right. Fine. All right. Stop. All right. So homework 3, this is question 2. All right.
Yes.
So read that in. Let me see the data. Yep, there you go. Okay, all right, so now go back to the NOVA. All right, so in line 9.
Okay.
In line 9, let me go on to chat. I'm gonna write something for you. Do class data $, week. Do this in line 9.
Okay, let me copy and paste. Okay, like that?
Yep, run that.
What is that for?
It's telling me what type of data is in weeks. Whoa, you don't have to run the whole thing again. You just have to run that one line.
It says no.
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 Okay.
Yeah, here on the bottom.
All right. Let me see your data file again. Just click on the tab that has it viewed.
Okay, here. Yeah.
That's weird.
It is.
Because it's capitalized. You've capitalized week.
Yes.
Capitalized week.
Okay, so here.
Integer. Okay. All right. Yeah. So now run the next line. Now run the class line again. Run line 9 again.
Okay. Factor.
Okay. Now it's a factor. Okay. Give me the first 6 lines. Do head data.
Head data.
Yeah, head data, not the whole. I don't want to see the whole thing. I just want to see the top.
Okay.
So line 12.
Line 12.
Line 12, head, open parentheses, data. There you go. Okay, so you have week capitalized, you have display capitalized, and you have sales. Okay, sales, tilde, AOV. Okay, run line 13.
13.
Okay, now run line 14. Okay, I don't understand what the issue is.
So yeah, the issue is that my total would be. Wait a second.
Yeah, your sum of squares. Your let's see. So you have 5 weeks. So that's all right. What? So you have 5 weeks. How many displays do you have?
I have 3 displays.
3 displays. Okay, so that's 2 degrees of freedom there. Go back to R.
Okay.
The sums of squares aren't correct, or they're not right for your.
Yeah, for my calculations.
Yeah.
Okay, so the sum of squares are not right. All right, so give me a minute.
That's how it is for mine too when I run it. My sums of squares are completely different.
Okay. All right, I need to go to my own files. Which question is this?
This is question 2.
Question 2. All right. I haven't saved that one yet. All right. There's my problem set 2 file. I don't know why it's not somewhere easy to get to. Sorry about all the silence.
No, you're fine. I was just like that for 3 hours yesterday trying to solve this problem, but
Yeah.
now you feel me. Yeah.
So let me go back to R.
I don't know how the other people did that. Honestly, like.
All right. All right. It would be nice if I would learn how to type. All right. I can't seem to see you anymore. Why can I not see you anymore?
I'm still sharing.
Okay. All right. So I'm getting the same thing that you guys got, 1277, 1279 for the sums of squares. Is that what you guys got?
On your R table, ANOVA table.
Yep.
On my Excel, I got 426 column residual. I got like totally different numbers.
Yeah, that's what I got too.
Okay, let's see. I don't have mine set up that way, so. All right, so what is the grand mean? So in your Excel file, what'd you get for the grand mean?
I got 126.2.
Okay. All right, so what did you get for averages across display?
What would that be?
Averages by display? Well, it depends on how you're going to have your data set up. I have my displays in columns.
Oh yeah, column means, right?
Mm-hmm.
You just for A I got 126.4. For B I got 137.4, and for C 114.8.
Okay. And what do you have for row means?
You might as well just check my screen. I'm sharing so you can see faster.
Okay. All right. Let me get back to the point that I can see you. All right. Okay. So show me your sum squares residual.
Sum of squares residual.
Yeah, just
right.
click on one of those blocks so I can see what's in there. Can you click in the formula bar so I can see what's highlighted?
Sure. Here it's
Yep,
this.
yep, that's fine. So that minus that minus G6 plus oh yeah, D16 is not the the last thing is not the grand sum but the grand mean.
Yes, it's the grand mean that I'm using here.
Oh, D16. Okay, gotcha. All right, I was looking. Okay, gotcha. All right. So that looks like that's correct. So that's 524.13. And what did I get? Oh yeah, there it is. Okay, all right. So that's what I got for sum squares residual.
524?
524.1, yep.
Yes, sir.
That's what you got also in R?
In R, we got for residuals 524.1, which is correct.
Which is what you got in your Excel spreadsheet. Okay, go back to your Excel spreadsheet.
Mm-hmm.
All right. Let me see your formula for sums of squares within.
Within,
Let me see. Okay. That is not how one does sums of squares within.
okay, but I think, wait,
because there is no sum squares within here. There is no sum squares within, because you don't have any replication.
yeah,
Sum squares residual is sum squares within. So show me sum squares rows.
rows, sum
Yep.
of squares,
Sum squares total.
rows, right here.
All right. All right, let me see that. All right, those are all from the grand mean. Okay, so what is that value?
The value is 426.
426. Okay.
35.
And in R, it's giving you 3 times that, I'll bet.
Yes.
Is that right?
Yes, it's giving me 3 times that.
Yes, it's because you're not weighting it by the sample size.
What do you mean by that?
I'll show you. Let me go and find the.
Isn't the sample size the same here?
Yeah, but it's 3 and you're not weighting it. So just give me a minute. So this is an unreplicated ANOVA.
Yes, the replicated ones are number, I think, 1 and 3 or 2 or 4.
Unshare your screen.
Unshare.
So I can
Okay.
share mine.
Give me a second. Stop share. Okay.
I'm going to share my screen. Go back to the PowerPoints on the unreplicated ANOVA and look at the formulas. The sums of squares is the means, but then it's weighted by the number of columns that you're averaging across. And for the blocks, it's weighted by the number of rows that you're averaging. So you've done the mean minus the grand mean squared, but you didn't multiply times the number of columns.
Which is 3 columns, right?
3 columns, yep.
So
And
it's
so,
times 3.
yeah, so if you do that, I'll bet you're going to get exactly what you have in R. Now share your screen with me.
Okay, so I just multiplied that by 3. Share screen. Okay, I multiply that by 3 in the beginning of the formula.
1279. Now go to R.
Now go to R.
1279.1.
Yes, but how about the display? Should I always? I'm sorry.
It's multiply times the number of rows. So you have 5 rows. So multiply that times 5. No, not
This,
that. Sum squares column.
Sum of squares columns.
Multiply that times 5.
So the columns I multiply by the number of rows, and in the rows
Yep.
multiply by the number of columns.
Yes, because those row means are based on 3 observations. Each row mean is based on 3 observations. Each column mean is based on 5 observations. So is that 1277? Is that what you see in R?
1277. Yes, perfect.
Yes, it is.
It's correct. Okay, but yeah. For this is unreplicated. Can you make it also an example of a replicated one so we can do the other 2 by ourselves before submitted?
Yeah. So, well, where's question 1?
This is question 3. Let me get question 1 here real quick. Question 1, homework 3. Yeah. Okay, so this is what I got for question 1.
And does that match what's in R?
So yeah, I tried to run in R, but you couldn't even read the file. I don't know why, but I can do this right now.
Okay, let's go get your data file.
Okay, so this is question 1, so just need to change that. My class would be what?
Well, let me see the data file.
Okay.
Like read in the data file and then show me what it looks like. No, read in the data file and show me what it looks like.
Oh, the data
In R.
file.
In R.
R,
In R.
right here.
Yeah, so read it in. So you've got homework 3, question 1. Run that line. Run line 5. Okay, now show me what that data file looks like. Run line 6. Yeah. Okay. Scroll up so I can see the top. Okay, wait. Oh, it's because you have your data in wide format. So get it out of wide format into long format.
How do I do that?
Well, there's code that is written, so you can use the code that we've used before to convert, or you can just do it in R or in Excel. It doesn't really matter to me. Where's the code that we had for doing that? What script was that in? That was in the one-way ANOVA, wasn't it?
I think was this one right here in class 1. Wait,
Oh,
no,
let me see.
this is our code. I think it was this one right here. Yes.
Oh yeah, so that's basically converting it into long code, but that was for a one-way ANOVA.
Yes.
So the reason it's not reading it in is because it's in wide format rather than long format. So you might stop sharing your screen.
Okay.
I'm going to share my screen with you. I just had it a minute ago. Where is it? Not there. This is why I have different formats. So this is what my data set looks like. And I actually gave my regions Roman numerals so that it would treat it like factors.
Mm-hmm.
So this is the format that you need to have your data in. And whether you do that conversion in R or whether you just do it in, so this is region 1. This is all region 1 right here. And then within region 1, you have 3 red on whites, you have 3 mogollons, you have 3 membres, and you have 3 boldface.
How do you transform your data to, wait, just give me a second. Question 1, I'm gonna open here. Okay, so how do you put the Roman numbers on the left?
I just type them in. This is just the data set.
Okay, so first region, then type.
That's what I did.
What?
And then
Okay.
the number. So each treatment is in a column, and then your response variable is in a column.
Okay.
Grace, is this same issue you're having?
Not this issue, but the last issue was, but I'm still, after this, I'll ask.
Okay. So Athos, if you rearrange your data into long form, it should work just fine. The same code that you're using for the other ones should work, except that in your R code for this one, because it is, so for this new data set, well, I have it right here, Q1. You can still see my screen, right?
Yes.
So this is what my data look like when I go through there.
Mm-hmm.
Okay. So when I get class region, because I've used Roman numerals, it automatically treats that as a factor. So I don't have to do anything funky. So I don't have to do any of this conversion. And then what I'm going to do here is I'm interested in number as it's determined by region. And in this case, I want to use an asterisk rather than a plus because this is a replicated version.
Oh, so you multiply it, right?
Yep.
Okay, let me take a picture of this. Don't leave. And can I submit it before 5 p.m. today? I gotta work right now, so.
Yeah. Yeah,
Okay,
that's
awesome.
when it's due. And
Perfect.
then it gives you the ANOVA. So there are differences in region, there are differences in type, and there's a type by region interaction, and then there's the residual term. And I think all of those degrees of freedom match up. So
Okay.
that's the only issue.
If I have any issue, I will email you, but
Okay.
it shouldn't be that bad. I'm gonna finish work and jump in R and finish this.
Okay.
Thank you very much, Dr. Klowinski.
All right. Okay, Grace, so what's up with you then?
Okay, I
Yeah.
think mine, something that I'm lacking is the class, the thing that you put in the chat.
Okay.
The class. So
share your screen with me.
okay. Hang on.
See, Athos didn't think that we could do this on remote
No.
connection.
Wait.
Go down to the bottom of your screen. There's a little share screen
Yeah,
icon.
it told me that I have to allow access.
You have to allow access?
Yeah, it says like I have to go to security and privacy on my.
Oh, because it's yeah. Okay, we'll go and do that.
Okay, it says Zoom will not be able to record the contents of your screen until it is quit. So I have to quit Zoom. So what if
No,
it?
I'm recording, so you don't have to worry about recording.
Oh, okay. But it asks me to leave the meeting.
Okay, well then leave the meeting and come back. Leave the meeting, fix your security stuff, and then come back.
Okay.
Hey, Grace. Is allowing you to share now?
Okay, let's see. Yes. Alrighty.
Okay, cool. All right.
Okay.
Which one are you working on?
Well, so for each one of these, do I have to have that class data code?
Okay. It's just if you have anything in there that is numbers that you want it to treat as a treatment level, it's probably reading it as an integer, and so you have to tell it to not do that.
I think that's what it's doing because it gives me weird degrees of freedom.
Oh, okay. So which one is giving you weird degrees of freedom?
Hang on, let me clear this real quick.
Okay. All right. Cool. Fruit. All right. Let me look at the data sets. Scroll.
Do I need
slowly.
both of these?
No. Well, I don't know. Let me see. No, you just need the whichever one is appropriate. And this is a unreplicated design. This is
So I just
no,
need the
no. This is
plus.
no. This is a replicated design, isn't it? Let me.
Not fruit. Fruit's unreplicated. Number 2.
Oh, this is number 2. This is unreplicated. Yeah. So you don't need that second one.
Okay.
And if you run that second one, it's going to give you the same answer as running the first one.
Okay.
It's just not going to give you it'll give you an interaction term, but the interaction term is actually residual variation. It's not explained by the 2 main terms.
Okay.
So, yeah. So, so since week is a number, do class fruit $week.
I wouldn't need to do that for any of the other ones.
Only if you have numbers in there.
Only if you have numbers.
Yep. So when you run that line of code, integer. So now you have to change it to as factor. So fruit $week on line 28. Fruit $week. Assignment operator. Less than dash. As factor. As dot factor. Parentheses. Fruit $week.
Okay.
Run that line. Now run line 27 again. What? Run line 27. Factor. So now it's factor. So
should
now
I
do
put-
analysis. What?
Should I put line 27? Should I move that to line 29?
It doesn't need to be. You can just flip up there and do it. Or you can put it in line 29 if you want. Doesn't matter.
Okay, well, I'll run this for now.
Just run that. And there it is, 1279, 1277, 524. That's exactly what you should have gotten in your Excel file if you were doing your Excel file correctly.
Yes. 1279, 1272. Okay, got that.
So that's what the issue was. It was not giving you what you wanted because you didn't have your treatments identified as factors.
Right. So do I have to do that for all of these?
Well, I don't know. Let me see your data file for pottery. No, you shouldn't. So if you do class pottery $region, it should show it as a factor.
Yeah. So
Yeah.
we're good?
So that's fine. Yeah. So run this guy. Run line 11. Oh, but this is replicated, so you need to delete lines 11 through 13
Okay.
because this is a replicated design.
Okay, so I would just need.
You need the asterisk version because you want the interaction term.
So do I need the LM?
No, it doesn't matter. You could do it either way. You can do AOV or LM. It doesn't matter.
Okay.
Do summary analysis too. Yep, there it is.
Okay.
And I think that's exactly what I got. Let me go and check my R code real quick. 7365. Yeah, that's exactly what I got.
Okay, but for this one, when I look at my Excel sheet, I need to do the sums of squared times the number of.
So this is in the PowerPoint that is 2A ANOVA with replication. And
Okay.
so the formulas for this are found in slide 5. And once again, these are all weighted by the sample size and of the individual, the sample size within, as well as the number of rows that or columns that you're doing this across.
Okay, so I'm looking at it. It says for rows times NQ.
So Q is the number of columns, P is the number of rows. So your columns value is weighted by the number of rows. Your row value is weighted by the number of columns. So in that way, it's just like the other one as well.
Okay.
Okay.
So,
So that's your problem probably. If you go and look at, so I posted the Excel file for this as well.
uh-huh.
It's called two-way ANOVA example, I think.
Yeah, I think I looked at that.
Yeah, if you go and look at that and you look at the totals, sum squares rows, you're going to see that. Let me share my screen with you now.
Okay. Oh wait, I need to unshare.
You need to unshare, yep.
Okay, hang on. How do I get back? Okay, there we go. Would I press pause share?
No, there should be a stop button up at the top of your
Oh,
screen.
stop share. There we go.
Yep, there you go. So I'm going to share my life with you. So here's the Excel. There's an Excel spreadsheet on
Yeah.
Moodle, and it looks
Mhm.
exactly like this.
Mhm.
And this is for the rat fat data. But when you go to sum squares rows, you see that it's looking at the means minus the grand mean squared, mean minus grand mean squared, but then it's weighted by the number of categories and the number of observations in each one.
Okay.
And I'm sure that's what you're not doing.
Okay, gotcha.
So we have two categories here. So this is sum squares rows, but we have, in each row, we have two categories, fresh and rancid, that you're averaging across. And within each of those, you have 3 observations.
Okay.
So this row mean is actually made up of 6 observations. So you have to, oh crud, I've messed up my formula. Undo. So this is weighted by 6.
Okay.
2 for fresh and rancid, and 3 for you have 3 observations within males. So fresh, 3 observations within rancid.
Okay, gotcha.
So I think once you fix that, you'll probably be getting the same numbers as you get in R.
Okay.
Don't forget the weighting issue.
Right. Okay, I got 1 digit off.
That's like a rounding error kind of thing.
I think so, but well, actually R rounded theirs.
Okay, yeah, okay. But otherwise,
Okay.
that's giving you the right answer.
Yes, that makes
Okay.
more sense.
Yeah, you always have to weight by sample size.
Okay, then I should be good.
Okay. Yeah, so if you're having problems in that one with that issue, you're probably having problems in all the rest with that same issue.
Yeah, I'll go back and do the others again.
This is why I have you do these things by hand.
Yeah, I understand that.
Okay. All right, what else?
Let me see. I feel like I should be good
Okay.
to do the rest of them since the other 2 are one of each of these, so I should know what to do now.
All right.
Thank you for your help.
Sure, no problem. That's what we're
All
here for.
Okay, see you on Wednesday.
Okay.
Bye.